You found the skeleton. How would you tell people that this happened? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey there YouTube, the Dapper Dinosaur here. This is the second of two parts of a short series addressing a video by Cindy Lincoln. Now her video was about an hour long, and towards the end of it she reiterated many of her claims that she had already made. In the interest of brevity, I have decided that I will not be repeating myself, and if I have already addressed a claim, it simply won't be included in this video. That being said, it is certainly not true that all of the claims she made in the later parts of her video were simply repeats, so there is still plenty for me to respond to. Also, like with the first part, I wrote the script as I watched the video, stopping to check sources, write responses, etc. The only exception is this introduction, which was written after I had written the rest of the script but before I decided where to put in a part break. I just want to say before we get into it, thank you for watching, and if you could please subscribe and turn on all notifications. And if you like this video, give it a like and a comment, it really helps the channel. Anyway, here's Cindy.
All over the world. Now we're moving on to Nova Scotia.
At this point, I have to wonder why. We've been shown 6 pictures of sedimentary formations, 1 of igneous formations, none of which have even a whiff of possibility of having a flood as their cause, although I suppose a basalt column could form under a flood. So at least with Isla Espiritu Santo we have that. At no point were we told why it would take a flood, any reason to think that it happened fast beyond the intuition of Cindy, which, much as I love her, is highly motivated for young Earth creationism to be true. And so far I can't see any evidence that she checked the literature on any of these structures to see what they're made of. Granted, it's not like I've had fun checking that literature, but it's necessary if you want to talk about a sequence of rock in any way that matters in terms of explaining its formation. Step 1 to explaining anything is to know exactly what you're looking at. But I'm going to stick with this for a while. Cindy directed me to this video specifically, and she's a friend, so here we go.
This is called the Goldenville Strata. It's a quarry in Canada. Again, these are marine sediments.
So off to check the literature again, and for the first time so far, we have at least some rocks that can be reasonably interpreted as flood rocks, with turbidite, silt, and sandstone. Unfortunately, these layers are also separated by things like slate and sandstone finely interlayered, forming seasonal laminae. So the formation as a whole cannot be explained by a single flood, because the layers associated with high-energy flood-consistent depositions are not continuous, but instead there are evident long periods of gentle deposition of fine grains.
That means ocean sediments. That means they're going to find shells in here. And you'll get a really, really exaggerated demonstration of the hugeness of these deposits. This formation covers over half of Nova Scotia.
Yes, it does. Because 1, in the Paleozoic, water levels were higher, and 2, this area was lower in elevation. It has since been uplifted. You combine that, and what you get is a lot of marine sediments now on land.
Okay, that can't be a river flood.
True, but it also can't be a flood at all. Too much of this rock has no known way to be laid down in a flood. And here's the thing, sedimentation experiments are a thing people can do. If young Earth creationists wanted to find ways to explain things like non-density sorted layering of fine-grained sediments without flocculation, resulting in layers consistent but essentially randomly ordered by grain size and density during a flood, they can do it. No one could possibly stop them. Until they do and find a mechanism for depositing what we see in nature, then frankly they're on the same intellectual level in geology as flat earthers are in geography. There simply is no reason to take flood geology seriously until flood geologists do the work. And based on the examples of flood geologist work that I'm familiar with, such as Andrew Snelling and Steve Austin, not only are they refusing to do the work, they're deliberately lying about the work that they do in fact publish in support of a global flood. I have yet to see any paper published anywhere that both supports a global flood and is not dishonest. If you're watching this and you know of one, please let me know. I'd love to look at it with the help of my geology friends.
And it's recorded as being 29,000 feet thick. Okay, your average home has about an 8-foot ceiling. Your dad's probably 6 feet. Okay, so let's just for ease of math say that your house, a 1-story house, is say 10 feet high. 29,000 feet would be 2,900 stories. I think the tallest building in the world is only 300 stories. This formation is 2,900 stories high.
I do not contest this, but I also am really curious to know what it is that makes the height of the sequence relevant to the question of how long it took to deposit and how long ago that deposition occurred.
What kind of a marine environment could lay down that much sediment? That means the waters had to be way, way higher than that to move that amount of sediment, right?
Not necessarily. The area could have undergone subsidence during much of this period, and further the ocean levels were higher at the time, so oceans were deeper. And of course, only the lowest layers would need an ocean that deep, even if we assumed constant height for the bottom portion of the crust in this area. The higher layers would of necessity been deposited in a shallower ocean under that scenario.
I tell the story in the Science Center tour of when I used to go to college in Nebraska. They find shark teeth in Nebraska, among other marine evidences.
Okay, but Nebraska shark teeth are Mesozoic and from the western interior seaway, so in order to connect them to flood deposits, you would first have to establish the fact of a global flood. Since this has not been done, there is no reason to think they share a cause. The existence of marine rock on land is not per se evidence of a global flood, and so the fact that there is marine rock in more than one place in North America does not indicate a global flood, especially since they are from extremely different portions of the geological column, which, even if times associated with it are off, still indicates that vertically separated layers are not of necessity causally linked to a single global event. That's the whole thing flood geology must attempt to demonstrate. We can't simply assume it at the outset.
And as a geology student, they would tell me Nebraska used to be underwater. And then when I was in California, I visit the Petrified forest. The only way you can petrify trees is if they're underwater. And they say, again, this whole area was at one time underwater.
This is another one of those kind of things. Petrified forests occur in water-saturated sediments. This could be underwater, but can also simply mean under the surface of a swamp. And the fact is that all petrified forests are in terrestrial deposits. So again, until flood geologists show experimentally or even theoretically a way for these rocks to be deposited by a flood, we can say with high confidence that we know they were not. So as of now, petrified forests are the result of forests in wetlands.
You have to bury those logs. You can only bury a log before it rots if it's mud flows.
That's simply untrue. Logs and stumps often remain relatively intact for years, meaning ordinary deposition is sufficient to cover one before it rots. Especially since at the time most petrified trees occurred, the main structural component of trees, lignin, had no way of rotting, because the modern fungus that feed on it had yet to develop. Now, granted, Cindy might contest this, but to do so, she again would have to start from the plausibility of a flood, which has yet to be established.
Large-scale mud flows, not river scale.
In fact, we know this to not be the case because we find soil horizons in the layers containing these trees. That means soil had time to form in the middle of the deposition of these layers.
And I went to Europe for my honeymoon. And again, some of the places we visited in Europe said this area was at one time covered by water. If you just Google a satellite image of the Earth, you will see the entire Sahara Desert looks like there's wash patterns on it.
While most of what is now the Sahara has been underwater at various times, what you see now is primarily wind-driven sand dunes, because sand is what covers most of the Sahara.
Like the whole thing used to be underwater, and you can see where the water rushed off of it.
You can't, though, because that never happened. The Sahara was underwater during sea transgressions, and we can tell because, again, the marine deposits aren't flood rocks, unless flood geology has new sedimentation experiments they're hiding just to make themselves look foolish. The area is not characterized by large-scale flood runoff, because if it were, it would look like the channeled scablands of eastern Washington, which it does not.
When I was on an airplane coming home from Oregon to Alabama, I could see the same thing in the United States. As you're going across Montana and large parts of the United States, you see wash patterns, drainage patterns that really look like the whole area used to be underwater.
Yes, those are areas that experienced localized flooding after the last glacial maximum. And that's not just according to science, that's according to flood geologists, all of whom place the last glacial maximum after the flood. But we do not see that everywhere, which we should if only a few millennia ago a global flood had occurred.
That would take massive amounts of water. And when the Appalachians and the Rockies both have shells on top of them, that means the water had to be higher than those mountains.
No, it doesn't, because the Appalachians are the result of folding like the Himalayas, which are still growing, so they were pushed up from the seafloor. And the Rockies are currently growing and are volcanic mountains resulting from the subduction of the Farallon and Pacific plates under the North American plate, which means again they're growing up from what was once low elevation land, or in the past essentially continental shelf. For this argument to work, we would have to have good reason to think that these marine environments were deposited on the mountains after they formed but were still underwater, and therefore they would have to be largely undisturbed. But they are anything but undisturbed. They are uplifted and folded in every which way. As a result, we know they absolutely did not form in situ on these mountains. The mounts definitively formed after the marine sediments were deposited. Now, could that have happened underwater? I guess, but the fact that the sediments they're made up of are marine does not in any way indicate that they were.
You're talking a lot of water. And yes, there's been uprising, which would account for the tilt here. You see, these are not horizontal, they're tilted.
In fact, this area of North America is still uplifting.
Now, because of plate tectonics, we know that the planet, it's kind of like opening and closing. The planet pushes and pulls.
I'm not really sure what this means. I hope it's clarified.
You'll see that there are places where the layers have been pushed. Kind of like the picture Kent Hovind shows of a rug. If you push a rug, then parts of it will come up.
Ah, this is called folding, and honestly, Kent's explanation of pushing a rug against a wall or two rugs together is actually pretty good. It's one of the few things I think he gets right and explains in a way that won't mislead people.
But what you might need to think about is, doesn't that mean these layers were all wet at the same time because they're folding smoothly?
Now, we've already covered the plastic deformation of lithified rock has been experimentally demonstrated for over a century. I'm going to skip the rest of this folding argument because it's just a repeat.
The cementing process where mud hardens to rock only takes a couple of days. If you've ever seen a sidewalk, you'll notice it goes from wet to hard in less than a week.
Yeah, with calcium oxide as a cementing agent, but that's not the cementing agent in natural sedimentary rock. The closest you get is calcium carbonate, which precipitates out of water into crystal formations that can cement rock together orders of magnitude more slowly than quicklime or calcium oxide. That's why humans turn limestone into quicklime to make cement. Again, I'm skipping this bit as we've already covered it. I'll come back when there's a new point presented because I can't make my audience listen to a repeat of the first part of this.
Here are some more really, really cool examples of folded layers.
And those folded layers have evident cracks, which are the result of folding already lithified and hardened rock, so we know it wasn't soft. Because if it were, then we wouldn't see that kind of fracturing. That's why when Andrew Snelling decided to lie about folded strata, he strategically placed some monkeys in front of the fractures that he said weren't there.
Where it goes from like a turquoise color to a brown to a turquoise to a brown to a turquoise to a brown. So does that mean that one year something turquoise was deposited and another year something brown was deposited?
No, it takes much longer than a year to change depositional environments so severely in most cases.
Or could this just represent what the water normally does? It sorts things by density.
Sure, if that were sorted by density, but it isn't. It's got repeating elements. If the layers were sorted by density, then all the high-density stuff would be on the bottom, but instead, here in this picture and all over the geologic record, we see high-density layers interspersed with low-density layers. Cindy is looking at a picture that visibly cannot be sorted by density, and simply saying that maybe it is.
If you have a mocha where it has both coffee grounds and cocoa powder, if you have it in a glass cup, you can see the coffee grounds will settle out first because they're heavier or denser, and the cocoa powder will form a layer on top of it with a perfectly straight line in between because cocoa powder is lighter.
Yep, this is actually an excellent example of density sorting. and results in what is called graded bedding. Now, in rocks, we tend to have many bits of slightly different sizes and hydrodynamic qualities, so you won't get distinct and obvious layers in a graded bedding deposit, and graded bedding is exactly what you tend to find after a flood. So when flood geologists find their globally correlated and horizontally extensive graded bedding deposit, we can talk about that as a remnant of the flood. So far, no such thing has happened, and we've checked just about everywhere. The apparent stratification you get in your mocha is only because you have artificially selected two very different grain types, coffee grounds and cocoa powder. Nature does not typically do this.
But it has to happen in water. Here is another example of sorting in water. Water sorting things into layers with a perfect line, just like we see.
But Cindy, the one on the right isn't sediment grains, it's completely different liquids. And the one that does in fact have natural type sediments on the left is visibly a single layer of graded bedding without internal stratification. Those layers you're seeing are at the bottom graded bedding without internal stratification, then water with extensive suspension of very fine grained sediment, and on top just a bunch of bubbles. This directly contradicts the idea that the geology of the Earth can be the result of a flood. This is an actual sedimentation experiment that disconfirms the flood hypothesis.
By density. So this is my homemade nut milk. You just take nuts and you put them in a blender with a little bit of water until they get broken to small pieces. Then you add more water, and you have homemade nut milk. You can do almond milk, sunflower nut milk. But notice how the heaviest particles are at the bottom, medium particles on top of that, then water, and then the foamy lighter stuff at the top. It's amazing. Perfect layers.
Honestly, I'm at a loss. I'm sitting here staring at non-stratified graded bedding at the bottom of a jar, the part that is relevant to sedimentary deposition, and being told that this is stratification. I feel like I'm standing in a hurricane and being told it's a sunny day with a light breeze. I don't think Cindy is being dishonest, but I honestly don't know what to say other than her own almond milk recipe, on its own, shows why a global flood cannot be the cause of the sedimentary layers of Earth.
Note the perfect boundary lines, just like we see on the Earth's layers.
But that's between the water and the sediment and the water and the foam, not within the sediment. What matters is what's within the sediment that's been deposited, because we're talking about sediment deposition. If you dry that jar up, two of those layers would be gone, and you just had the top of that graded bedding as fine-grained sediment in a single unstratified layer. I can't possibly state the degree to which this experiment devastates Cindy's point. It blows it out of the water. It's a nuclear bomb to the whole idea.
Here's another experiment you can do if you don't have a blender. At the bottom you'll see maple syrup with a nut. You know, nuts and bolts, they're metal and heavy.
A density tower of different liquids does not in any way relate to sedimentation in geology, so we're going to skip it.
So if all the mud and silt and minerals and shells and dead stuff, where coal comes from, coal is a fossil fuel, right? Crude oil is made from dead stuff too. Shale is packed full of dead stuff. So if we have all this stuff on the Earth that used to be in water, where did all this water come from?
The water cycle.
And how did it cover large land masses?
Rain, change in elevation, and change in sea levels.
Well, this is a map of the world's groundwater. Okay, that would be water that's under the ground. You know, everywhere you go, you can dig a hole and hit water.
Yeah, basically, if you can dig deep enough, which in some places is a big if.
Some places there's underground lakes. There's huge amounts of water under the ground. And the scriptures teach in the 600th year of Noah's life, in the second month, the 17th day of the month. Interesting, God gives an exact time as though it were a real event in history. I know Aaron Ra and AJ are probably going to disown me. Maybe Pelagia too.
I'm kind of flattered she didn't say I would disown her. Thanks, Cindy, because I won't. We don't have to agree on geology and biology for me to support you as a friend and as a victim of domestic and religious abuse. Those things are more important than how bits of rock settle out of water.
But we're just trying to think about science and what's real here, and if it fits with what's in the scriptures. So, the same day were all the fountains of the great deep broken up. Okay, fountains, that's a water fountain, right? In a deep place, broken up. If you look on the right, you'll see where the earth is indeed broken up.
But those fault lines aren't over aquifers, they're over the mantle of the earth. There's no way for extra water to come up from them and add to the total surface water on Earth. Even hydrothermal vents are actually recycling water from above the crust, not drawing on some reservoir under the ocean.
They're called, it's called plate tectonics. The globe is actually broken into plates that right now are moving very slowly, but in the past could have done so catastrophically.
The problem there is that requires energy, and when catastrophic plate tectonics researchers do their own math, that is, people friendly to this idea, we get that we would need enough heat to boil the oceans like 4 times over. Noah wouldn't need a boat to survive that, he'd need a radiation-shielded spaceship, and there wouldn't be any liquid water to deposit rocks, everything would just be lava.
And at the same time that the groundwater is released from the breaking up of the earth, the windows of heaven were opened. Genesis 7:11.
But there is no dome in the sky with windows to open. This is just the Bible's ancient Near East flat Earth cosmology that young Earth creationists don't take literally, because that is a bridge too far even for them. But the only difference between a young Earth and a flat Earth is how long we've known this idea is wrong.
And then, after the flood is over, in Genesis 8:23, it says, "The fountains also of the deep and the windows of heaven were stopped."
So that means they were plugged, meaning the imagery is of both drawing from a huge reservoir of water that exists beyond the part of the world that humans experience. And the conception is that of a flat Earth sitting amidst the vast cosmic ocean with a dome separating the waters above and the rocks of the Earth separating the waters below. God removes the stoppers of the great deep and opens the windows in the firmament to let in the waters of the cosmic ocean. That's the literal interpretation of Genesis. And if you think that's silly, then you think taking Genesis literally is silly. Just go with that.
Now, the fountains of the great deep, if they would have closed, that would explain why you see the smushed up, bent layers. If the plates are closing and going back together, so the fountains of the great deep are closed, then that would explain why the layers are smushed that we just saw and tilted.
I think here she means folded, and I guess, sure, that might cause some folding if the plate boundaries all opened up like flower petals, but remember, the plates are sitting on the mantle, not water. So if they open up, then what would come out is lava, not water. I guess flood basalt is a kind of flood, but it's not really the kind of thing you use a boat to survive. You really can't survive it besides just being far away. And if it's global, you can't get far away without just leaving the planet.
You'll notice at the bottom of the map it shows divergent, which is spreading. If something diversifies, it's getting more and more far apart. And then in the center it says convergent. That would be where the plates are being smushed together instead of pulled apart. And you'll see the red zones are where this land movement not only releases water but also magma.
But this land movement doesn't release water. That's just not a thing, unless Cindy wants to send me some citation to the contrary. Moving solid silicates over a rocky high-viscosity mantle doesn't release water. There aren't subcrustal oceans for the crust to slide across. Mostly because they would immediately be squeezed up onto the surface by the sheer weight of the crust, and then bam, no more water reservoirs under the crust. The groundwater Cindy shows is in the crust, under the ground, but not under the crust.
So you see volcanoes at the same boundary areas where the plates come together and pull apart.
If you check, it's actually mostly where they pull apart, because that's where the lighter mantle rocks can melt, forming magma chambers. The mantle is made of heavier stuff, and while it does flow, it does so at a slow rate, and short of massive amounts of heat from lower down. As you can see in places like Hawaii or Yellowstone, Mantle materials tend not to form volcanoes that just erupt. So divergent plates usually result in milder geothermal activity like the hot springs of Greenland or suboceanic vents. Not that you can't get divergent plate volcanoes, just that they're less frequent.
And the rain from heaven was restrained, and the waters returned from off the earth continually. Okay, so in order to make the waters run off the earth, you're going to have to slightly lift the earth so the waters will rush off.
Okay, so now we need evidence of a global, more or less simultaneous uplift of most land on Earth. Good luck. After this, Cindy once again tries to say that the whole globe is covered in the remains of flood runoff, but again, since almost none of it actually is, and we've covered it, I'm cutting that out.
And the waters returned from off the earth continually. And after the end of 150 days, the waters were abated. That would mean off the land and into the oceans. Cool, huh?
Whether it's cool is subjective, so I won't contest that, but we'd still need evidence of this, and there really is none. Simply declaring, contrary to every expert, as well as just a simple satellite view from Google Earth, that the whole planet looks like the channeled scablands isn't going to cut it.
Now, here are some examples of water rushing off the earth. So you'll see that at one time, all these layers were connected, kind of like the horizontal striping that we saw, but then a big water rush happened and rushed a lot of the sediment off and only left these little pillars.
This is an example of a badland, so called because they are extremely difficult to traverse except in the air. Fun fact, the term badland is actually a calque from the Lakota term makosika, which I probably pronounced wrong, which simply means bad land, and was a reference to the fact that the land was essentially useless for humans since it couldn't be crossed, hunted, or cultivated. I just like to toss it in there whenever a Native American language influences the way we speak today. So we know how badlands form, and we know they're not flood runoff. They're what happens when soft rocks are weathered by heavy but infrequent rainfall. We can see them forming today, and that's how they form. We can also see flood runoff today, and it doesn't make badlands. It makes smooth-sided channels with teardrop-shaped islands where the rock is hard enough to resist erosion. It's what we see on a small scale after normal local floods. It's what we see both on Mars and in eastern Washington where there were large-scale floods. This isn't an open question in science. Badlands do not form from floods. Period.
That's Bryce Canyon in Utah. You'll see the same thing in Monument Valley near the Grand Canyon.
No, Monument Valley is not an example of flood runoff or a badland. You can't simply look at any erosional feature and just declare it to be flood runoff. These are buttes, which means that as the whole surrounding area slowly eroded, the harder rocks of the buttes eroded more slowly, so that at present they represent towers. These have to form slowly, or the sharply vertical nature of the buttes will not be maintained, as high-energy erosion events will simply break large chunks of the structures off, which is in fact what we see in floods.
Here in Hormuz Island, Iran, also known as Rainbow Island, near the Persian Gulf, you have major tilting. Those had to be formed horizontally, and who knows what was being sorted. Something really cool, minerals or something that was purple and yellow and orange and gold.
Well, yes, it was definitely minerals, as that's what rocks are made of.
So it was sorted by the water, by density, into those nice little lines.
Nope, this isn't sorted by density, as we've already covered. Skipping ahead.
But you'll notice that all the layers that we have seen so far, none of them are soil.
Except we already talked about the petrified forests, which have paleosols. And sure, we didn't get a picture of them from Cindy, but that's on her, not science. The fact that Cindy didn't investigate deeply enough to come across the existence of paleosols and fossilized soil horizons isn't a problem for science, it just means she has a lot more work to do before she's ready to challenge science.
You can't have millions of dead things changed into coal from just a small swamp or lake.
Why not? What's the minimum area of a coal-forming location, and how do we know?
It had to be much larger scale.
Why? We don't get an answer.
This is an image that I took from the geologic column. I was Googling about the geologic column, and one of the images of it had this admission here.
The word admission in contexts like these just poisons the well. Science sources stating things that are well-accepted parts of standard models isn't an admission, even if you think it helps your case in your fight with science.
That all the limestone present in the so-called geologic column requires mud to be solidified, hardened.
Limey muck, not just general mud. They aren't the same, but once again I'm repeating myself.
Cementation. Particles glued together as mineral solutions harden. So in the previous slide, we saw calcium carbonate and dolomite are the mineral solutions that turn mud into cement.
Sometimes, and it's never quicklime, which is the stuff that Cindy needs it to be for her less than a week-long lithification that will fit all the lithification in the geological record into a year-long flood. She has basically gone from, because limestone is used in the production of cement, and cement hardens in days, then any sedimentary rock must be able to lithify in days, ignoring that it is not calcium carbonate used in cement, it's calcium oxide. And that on top of that, many sedimentary rocks are not cemented by calcium carbonate anyway. Basically, if almost everything about sedimentary rocks were not the way it is, we could accommodate a global flood. Unfortunately for the flood idea, things are indeed as they are, and that is that they are a way that precludes the global flood as an explanatory mechanism for any known features in the geological record.
Cementation can also happen from not just the crushed shells and the calcium from the hard shells and coral, but cementation minerals can also come from lava flows or volcanic ash. Actually, I'm not sure about lava flows, but volcanic ash. Silicates also cement particles together.
And just like with calcium carbonate, they are not quick-dry cements.
Here's just another really cool place where the earth is cut open, and you can see the layers that we walk on every day. This is red clay layers alternated with basalt. So it's red clay, basalt, red clay, basalt, red clay, basalt. So again, challenging the yearly thing. So we have a year where somehow clay is coming, and then another year where basalt is coming. So the environment changes that radically every year, where sometimes clay is falling and sometimes basalt is falling. Or you just have one large event where a lot of water is sorting.
Except water doesn't sort basalt. Basalt cools directly from lava flows. So to explain this, you need a situation in which lava flows, then sediment accumulates on top of it, lithifies, then more lava flows, and repeat this as many times as it takes. At least 4 times that I can see, all in the space of a year? And Cindy talking about how supposedly each stratum is supposed to take a year is already too fast. So noting that a year per stratum is too fast doesn't really make her idea of less than a year per stratum very plausible.
The geologic column uses words like carboniferous and trying to label each kind of a layer with a different age.
This is one of those kind of moments again. The names are assigned to units of rock that can be correlated horizontally across the globe, primarily through the identification of characteristic and widespread paleotaxa. The geologic column itself does not assign an age in years to these systems, though, only saying that some are older than others and younger than yet others. The absolute ages are determined by radiometric dating.
A great age of millions of years.
Well, as I said way back, but I think bears repeating, you can indeed derive minimum deposition times from most strata based on their physical and chemical makeup. So if we add up the evident minima, we can get a minimum age for the entire Earth, and it is indeed millions, not thousands of years.
So here we have the definition of carboniferous for the Carboniferous Mountains in Norway. That means it contains carbon.
Again, kind of. The Carboniferous is named because it does contain large coal deposits, but not all Carboniferous rock has coal deposits. Just like the Jurassic period was named for the Jura Mountains, but not all Jurassic rock is actually from there.
Which is the same as coal, which is smushed up dead things. How do you get dead things to be all smushed up into like one big slurry and laid down in a perfect stripe?
You have a lot of plants die in a poorly oxygenated bog in a world where lignin-eating microbes have not evolved.
Sorry to quote someone who might not be your favorite person, but billions and billions of dead things buried in rock layers on every continent of the planet.
In fact, so many that they couldn't all possibly have been alive at the same time, or we would have been on Gideon from Star Trek's Mark of Gideon, where living things were shoulder to shoulder and stacked on top of each other with no room, the whole planet encased in a living mass. Here's a link to a video by Dr. Joel Duff, a Christian, about this very topic, where he points out that just one genus of cephalopods have left so many fossils that quadrillions of them would have had to have been alive in a single year, taking up essentially the entire volume of the ocean they lived in if their fossil record is supposed to have been formed in 1 year of a global flood.
Not just shells, but check this out. I just found a fish fossil from the top of the Himalaya mountains. Okay, so why are we surprised? We already know it's a marine deposit, so we just need to know, was it at one time at ocean level where all the deposits were made and then it rose? And just coincidentally, every single mountain on the planet is like that?
No, not every mountain on this planet is like that. In fact, the Rockies have a nice mix of terrestrial and marine deposits alternating. A tall order for a global flood deposit.
And does that prove there wasn't originally water in large quantities on the planet?
There is still water in large quantity on the planet, that was never in dispute. And that's the last thing in the video that I haven't really addressed. Normally that would mean I'm done and that I talk to you guys later, but I want to take a little more time on this one. Cindy has some persistent but very basic misunderstandings of geology. The most obvious is that she keeps saying the scientific view is that each stratum takes only a year to form. This is simply not true. While an individual stratum could form in a year if it's a particularly quick-forming stratum, in generally a stratum is something formed over centuries on the short end. Another thing Cindy consistently mixes up is that not all layering constitutes a stratum. There are laminae within strata which appear as distinct layers but are still part of the same basic depositional environment. Third, she seems to consistently mix up calcium carbonate and calcium oxide, while also apparently thinking that virtually all sedimentary rock is cemented by calcium. Most of it is, but hardly all. Fourth, she is under the impression that all sedimentary rock is deposited by water. This is also not true. Fifth, she repeatedly indicates that strata are sorted by density. They simply are not. Within a stratum, we may get density sorting, which is also what she got in her almond milk, but each stratum is not less dense than the one below and denser than the one above consistently. Sixth, she thinks that high-energy events like flooding result in distinct layering within bedding in deposits. Again, her own experiment disconfirms this. They tend to leave behind smoothly graded bedding. The time her experiment did not confirm this is when she specifically mixed two pre-sorted types of sediment that had a characteristic and drastically different density and grain size. While this might be how her mocha works, it's not how rocks in nature work. Seventh, she consistently indicates that all folding in strata had to occur before lithification. But we have known for more than a century from laboratory experiments as well as field observations that this is simply false. We even know how to tell if sediments were lithified or not when the folding occurred, and while many times they were not, as in the wave in the Navajo sandstone, most of the times they are, as in the strata that Andrew Snelling likes to lie about. Now, I'm not saying that Cindy needs to have the same position as science on all of these matters, but if she or anyone else wants to seriously critique the science of geology, they will need to know what the consensus view is and why it is that way. Arguing against the straw man version of geology for an hour will not be convincing to anyone who has studied geology. Finally, there is an eighth persistent misunderstanding through this whole video, and that is that mudstone is a general term that applies to a large portion of the sedimentary rocks on Earth, and that it represents quick deposition. Here I am going to quote from a blog post by Stephen Mitchell, a Christian who is responding to a book by Dr. Timothy Clary, a young Earth creationist. The book is called Carved in Stone, A Geological Evidence of the Worldwide Flood. A link to the blog post, which itself contains dozens of sources for further reading, is in the description. I'm going to quote from a section specifically about actual mudstone and sandstone. For the sake of the listener, I have cut out of my quotation references to figures and inline citations. They can be found very easily on the blog in question by just doing a search for the term pelagite, Papa, Echo, Lima, Golf, India, Tango, Echo. Quote, the YEC claim that much of the rock record was deposited in the 1 year-long flood inherently includes the claim that sedimentary rocks were all deposited very rapidly by moving water. Geologists don't dispute that some rocks were formed quickly. The flood model proposed by Dr. Clary demands that all of the Paleozoic, Mesozoic, and most of the Cenozoic were deposited extremely rapidly. He points to a few articles that show selected examples of rapid deposition of muds and limestone. The fact that in some places these sediment types can be deposited quickly is taken to prove that all shales and limestones were deposited quickly. That is as true as saying that some cars are red, therefore all cars are red. Shale and mudstone. This logic is used with shales and mudstone. Dr. Clary writes, clay-rich rocks like shale and mudstone often exhibit fine laminations or thin bedded layers that only form by moving water, not stagnant water. How do we know? Recent empirical evidence demonstrates that laminated clays must be deposited in energetic settings by moving water. It is quite true that laminated mudstones can form from moving water, a fact that was underappreciated a few years back. When settling as individual particles, clay particles are so small that they settle incredibly slowly, and one bed wouldn't validate YEC models. However, as pointed out by the CIS book, particles can join together as flocculates and then be deposited much quicker. One has to wonder what type of flow rate would be required to deposit thick shales across the Delaware Basin if the average rate of deposition was 500 feet a day. It is not true that all mudstones are laminated or that all laminated mudstones formed in energetic settings by moving water. As an example, consider the Woodford Shale, one of the Devonian shales Dr. Clary described in the chapter on the Kaskaskia megasequence. Okoa et al. 2013 examined shales in detail, including the Woodford Shale, and found that it included both beds with high quantities of flocculates, hemipelagites, and beds with few flocculates, pelagites, as described in this quote. In this modified usage, hemipelagite is defined as rock composed of fine-grained sediments of biogenic and terragenous sources transported to the site of deposition by a variety of processes in which vertical settling may have been delayed by failure or flood-initiated flows, bottom currents, or other processes. Alternatively, the pelagite term refers to fine-grained sediments of mainly biogenic source that settle vertically through the water column under the influence of gravity, with minor influence of other processes that delay deposition. Schreiber et al. 2007 examined cores of the Woodford Shale, and they were found to have both kinds of beds. The slower accumulating pelagites were found to have more organic matter and higher permeability than the hemipelagites, making them the important beds for source rocks for oil. Hemipelagites incorporate terragenous material and probably represent distal portions of turbidite beds. Such beds may have formed relatively quickly, though a column of hemipelagites typically represents a lot of time. The pelagite beds form from the slow settling of very fine material. These are the beds that are responsible for creating most of the hydrocarbon source potential in the Woodford. It is not just correct to claim that all laminated mud-rich rocks were deposited quickly. Each pelagite bed represents many years of slow accumulation. Carbonates, limestone and dolomite. CIS also claims that limestones were deposited rapidly, as shown by this quote. Another long-held uniformitarian belief has been exposed as false. Flume experiments have verified that carbonate is not deposited slowly, but rapidly by wave and current action. Laboratory experiments demonstrate that water flowing between 10 and 20 inches per second creates ripples and laminated carbonate mud layers identical to those observed in carbonate rocks. Clary, quoting Schreiber et al. In 2013, wrote, "These experiments showed unequivocally that carbonate muds can also accumulate in energetic settings, and observations from modern carbonate environments and from the rock record suggest that deposition of carbonate muds by currents could have been common throughout geologic history." Notice that they say, can also accumulate, and could have been common. This is a long way from claiming that all carbonate muds were deposited rapidly, let alone all carbonate rocks. The original article by Schreiber et al. 2007 cites Shin et al. 1993 as a key example in the literature. Shin describes what he observed. During our reconnaissance 7 weeks later, we observed lime mud beds exposed in the troughs of submarine oolite dunes and ripples. The mud layers were underlain and locally covered by ooid sand. The mud beds were lenticular and up to 5 centimeters thick. There is no reason to doubt that some thin carbonate muds have been deposited by moving water, just like with mudstones. This probably was not recognized in many places years ago. Carbonate rocks are highly variable rocks that form by a fascinating variety of processes and in a wide variety of environments. In many places, the individual beds are characteristic of the environment, but more typically, the entire suite of rocks, features, and the setting provide the context that allows the geologist to understand the rock, how it was deposited, and the key changes that took place after deposition. It should be pointed out that when Dr. Clary argues that carbonate muds can accumulate in energetic settings, he is completely avoiding the issue of where such a huge quantity of carbonate sediment came from in the first place. The only time he addressed that issue is on page 160, where he states Austin et al. Believe that significant thicknesses of pre-flood sediments existed. Many years ago, I, that is Stephen Mitchell, not Dapper Dino, was charged with developing a detailed reservoir description of Mobile Oil Company's acreage in one of our fields in West Texas. We took over 2,000 feet of core and it was slabbed, sanded, and then described under a microscope, foot by foot. Many pieces were selected for special microscopic analysis, using thin sections, allowing even more detailed analysis. At the end of the study, I documented 6 major cycles of sedimentation. Porosity was controlled by carbonate sands and fossils that were deposited in ancient tidal channels in very discontinuous sandbars, just like those we find today off the coast of Andros Island in the Bahamas. The packages with the tidal channels were separated by zones of Permian supratidal above normal high tide deposits, made up of storm deposits and algal deposits known as stromatolites. All of the units showed features that made it clear that the area had been arid in the Permian, such as we find today in the Persian Gulf. These packages were definitely not deposited by tsunamis or any other rapid mechanism. I find the stromatolitic intervals from these drill cores and in many other places in the geologic record especially telling. These formed as sediment was trapped by microbial mats of cyanobacteria, showing alternate periods of flooding and exposure, typically by tides. Dr. Clary discusses stromatolites, but did not discuss how long they take to develop, or how the periodic flooding and exposure would have taken place. Periodic exposure periods are especially hard to imagine during a global flood, with sediment being deposited at rates of hundreds of feet per day. Modern laminations have been measured to grow at a rate of 1.6 to 5.6 years per lamination. Modern examples from Shark Bay, as pictured in CIS, have been studied and found to grow at a rate of approximately less than 0.4 millimeters per year. They determined that the classic columns found in Shark Bay developed over the last 1,000 years. Certainly rates may have been faster in the past, but there are limits to what we might expect. Examples are found throughout the geologic record with morphologies much like the Shark Bay example that CIS shows. Should we really believe they grew in a day? The examples I, again Stephen Mitchell, studied in core from West Texas prove even more difficulties for a flood deposition. Soon after they formed, they were exposed for a long period, leached out by fresh water, and the cavities were filled later with anhydrite, just as they do today in the dry climate of the Persian Gulf. Arid climates don't fit the flood model. Evaporites such as salt, gypsum, and anhydrite are usually taken as strong indications of periods of evaporation, often in arid environments. The CIS explanation of these rocks are unreasonable. For instance, he, Dr. Clary, reports salt and gypsum-rich rocks seem to be the result from ocean rifting, seafloor spreading. The Permian deposits in New Mexico and West Texas contradict this dramatically. No seafloor spreading was around at all. He wrote, salt beds are only deposited in underwater marine setting. So how did the ocean mysteriously and suddenly disappear, exposing a massive pure salt layer and then become a terrestrial deposit, all in the blink of an eye? Again, the Permian deposits contradict this theory. The Jurassic Luan salt is at a different scale. Dr. Clary claims that this is a problem for modern geology because we have no direct modern analog, and geologists are supposed to be constrained to strict uniformitarianism. Modern geologists are therefore wrong if they appeal to the present is the key to the past, or wrong if they say that there were processes that we don't have a perfect scaled modern analog for. The present is a great help in understanding the past, but not in every case. In this case, the present does help to understand the same sets of features from the past. It should also be pointed out that while Dr. Clary is correct that salt beds can be deposited in an underwater marine setting, he fails to provide a coherent explanation for how they could form at the astronomical rates required by a year-long global flood. Sandstones. 2 sandstone bodies are used in CIS as blanket sands that were supposedly unexplainable to modern geologists. They are 1, the Whopper Sand in the Gulf of Mexico, and 2, the Ogallala Formation in the Texas Panhandle. As it happens, I, again Stephen Mitchell, discussed the Whopper Sand when I wrote the A Texas-Sized Challenge to Young Earth Creation and Flood Geology. The sandstone body was an unexpected surprise when it was discovered, but in context it makes perfect sense. It was deposited as coalesced submarine fans. I refer you to that book for details. A description of the sandstones of the Ogallala Formation is included in this blog post, Llano Estacado in New Mexico, and Texas versus YEC and Flood Geology. Ogallala sandstones are part of a beautifully documented fluvial system that was deposited in the Pleistocene. CIS misrepresents the sandstone and then never mentions the ancient soils that make up the layers, which make the Llano Estacado the broad flat mesa that it is today. The calyces that hold up the mesa were deposited in a finely balanced semi-arid climate as ancient soils, paleosols. Paleosols are recognized throughout the flood interval as recognized by Dr. Clary. Tabor and Montanez, 2004, recognized 31 different paleosols in the Pennsylvania section alone on the eastern shelf of central Texas. As noted earlier, most experts agree that soils take a long period to develop. The flood model demands that they formed almost instantaneously. End quote. So we can see that many of these errors are not simply unique to Cindy, but they are pervasive in young Earth attempts at geology. As usual, I want to thank Mr. Wilford for helping me with the geology stuff, as well as Steve Mitchell for his extensive work critiquing the play acting that passes for science in professional creationist circles. Finally, I want to say that if you liked this video, please hit like on it. If you didn't, hit dislike and let me know what you didn't like in the comments. If you are a creationist and you disagree with me, then you are invited to message me and come on the channel to talk about where you think I got it all wrong. However, I will not debate in the comments as it's a waste of my time, since no one will see it. Thanks for watching. I'm the Dapper Dinosaur. Thanks for watching, but before you go, I just want to say a special thank you to my channel members and my patrons, especially those pledging $20 or above. Work in Progress, Benthoven, Cynically Skeptic, Denny5252, Ian Chen, John Ackerman, Chris Love, Landon Knoll, Yapetus, Mabbity Babbity, Sphincter of Doom, The Venerable Bede, and Patrick Dennis. As you probably know, YouTube is a very volatile platform, and from month to month my income on the channel can swing wildly. But the people you see on screen are directly supporting so that I don't have to worry too much about that, and the channel can keep going as it is, and perhaps even improving. If you'd like to join this team, there are links below to join the channel or in the description to join the Patreon. The Patreon starts as low as $1 a month, and the channel memberships start as low as $1.99 a month. On Patreon, you can even get a discount for pledging annually. If you do decide to pledge, you'll get access to an exclusive Discord server just for channel supporters, as well as early access to all of my pre-recorded videos, often up to 2 months in advance. Higher tiers will unlock even better perks. Now, if an annual or monthly pledge isn't right for you, but you still want to support the channel, there is a merch store down in the description, as well as an Amazon wishlist, just for me. And if financial support isn't something you can or want to do, then if you still want to help out the channel, please just like and share these videos and make sure you comment on them. It really helps the channel out. Thanks again for watching.